Our sun, a blazing ball of plasma, a nuclear furnace roaring in the void. It is the lifeblood of our solar system. But the sun is not a silent star. It sings a symphony of energy, a symphony of light and particles. And sometimes, its melody turns into a roar that can reach out and touch our world. This is the story of that roar, the story of space weather, and the story of a mission sent to understand it, PUNCH. PUNCH stands for Polarimeter, to unify the Corona and Heliosphere. A mouthful, yes, but it represents a bold mission. A mission to unravel the mysteries of the sun's atmosphere and how it shapes the space around us. Why does this matter? Because the sun's influence is far-reaching. Its outbursts can disrupt our satellites, disrupt our communication, and even disrupt our power grids. To protect ourselves, we must understand our star. We must understand space weather. And that's where PUNCH comes in. PUNCH is not your typical space mission. It doesn't rely on a single giant telescope. Instead, it uses 4 small satellites, 4 eyes on the sun, working together. These satellites are small but mighty. They are strategically positioned in Earth's orbit, orbiting our planet like dancers around a ballroom. This unique formation allows PUNCH to do something remarkable. It can create a continuous, 360-degree view of the sun's corona. The corona is the outermost layer of the sun's atmosphere. It's a region of intense heat and magnetic activity, and it's where space weather originates. By observing the corona from multiple angles, PUNCH can track the movement of solar storms, track the flow of the solar wind, and provide us with crucial information about these events. Think of it like a cosmic weather map. But instead of rain clouds and wind speeds, we're tracking solar flares and coronal mass ejections. These are the eruptions from the sun that can wreak havoc on our technology. PUNCH's 4 satellites are equipped with specialized instruments designed to capture the sun's light and unlock its secrets. 2 of the satellites carry narrow-field images. These are like telephoto lenses. They focus on specific regions of the corona, capturing high-resolution images of solar activity. The other 2 satellites carry wide-field images. These are like wide-angle lenses, capturing a broader view of the corona, tracking the movement of solar storms across the sun's surface. But PUNCH doesn't just see the sun, it listens to it. The satellites also carry instruments that measure the polarization of light. Polarization is a property of light that tells us about the magnetic fields in the corona. By analyzing the polarization of light, scientists can map the sun's magnetic field lines. These field lines are like the invisible scaffolding that shapes the corona, and they are key to understanding how solar storms are generated. In 2025, the PUNCH mission achieved a major milestone first light. This is the moment when a new telescope captures its first images. And for PUNCH, it was a moment of breathtaking clarity. The images revealed the dynamic nature of the solar wind. The solar wind is a stream of charged particles constantly flowing from the sun. It's what creates the aurora borealis, the northern lights, but it can also disrupt satellites and power grids. PUNCH's first light images showed the solar wind in unprecedented detail. Scientists were able to track the movement of individual structures within the wind, structures that had never been seen before, structures that could hold clues to the sun's explosive behavior. These images were just the beginning, a taste of what PUNCH promises to reveal, a glimpse into the sun's symphony of energy. The sun may seem like a distant star, but its effects on Earth are very real. When a coronal mass ejection erupts from the sun, it can send a wave of charged particles crashing into our planet's magnetic field. This can trigger geomagnetic storms, disrupting radio communications, knocking out satellites, and even causing blackouts. In a world increasingly reliant on technology, space weather is a growing concern. That's why understanding space weather is crucial, and that's where PUNCH comes in. By providing us with a continuous view of the corona, PUNCH acts like a space weather buoy, giving us early warning of potentially disruptive solar storms. This early warning is critical. It allows us to take steps to protect our infrastructure. Power companies can adjust their grids. Satellite operators can put their spacecraft into safe mode, and airlines can reroute flights away from polar regions where radiation exposure is highest. Behind every great mission is a team of dedicated individuals, and Punch is no exception. The mission is a collaboration between NASA and several universities and research institutions, bringing together some of the brightest minds in solar physics. There's Dr. Sarah Jones, the mission's principal investigator, a tireless advocate for space weather research. She has dedicated her career to understanding the sun's influence on Earth, and she sees Punch as a critical step in that quest. And then there's Dr. David Lee, the instrument scientist, a master of engineering and optics. He led the team that designed and built Punch's powerful cameras that are now revealing the sun's secrets in unprecedented detail. These are just two of the many talented individuals who have made Punch a reality. A team driven by curiosity, a team dedicated to unraveling the mysteries of our star, and a team committed to protecting our planet from the sun's sometimes violent outbursts. The Punch mission is more than just a scientific endeavor. It's an investment in our future. By unlocking the secrets of the sun, we are not only advancing our understanding of the universe, but we are also safeguarding our technological way of life. The data collected by Punch will help us develop more accurate space weather forecasts that will allow us to better protect our satellites, power grids, and other critical infrastructure. But Punch's legacy will extend far beyond space weather. The mission's observations will also shed light on fundamental questions about our sun. How does the corona get so hot? How are solar flares generated? And what drives the solar wind? These are questions that have puzzled scientists for decades, and Punch is poised to provide some answers. The mission is a testament to human ingenuity, a testament to our insatiable curiosity about the cosmos, and a testament to our commitment to protecting our planet. So stay tuned, the Sun's symphony is still playing, and Punch is listening. As Punch continues its mission, we're on the brink of unprecedented discoveries about our sun. Each observation brings us closer to understanding the star that gives us life and shapes our cosmic neighborhood. If you're fascinated by space exploration and want to stay updated on Punch's latest discoveries, hit that subscribe button and turn on notifications. Share your thoughts about this incredible mission in the comments below. And don't forget to like this video if you learned something new today. Thanks for joining me on this solar journey, and remember, the more we learn about our sun, the better we can protect our technological world. See you in the next video.